Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem. Solve d cube plus d squared minus d minus 1 into y equals to cos 2x. Firstly, let's find the order and degree of the given differential equation. Identify the highest derivative here. D cube is the highest derivative, so our order will be 3. And the highest power of the highest derivative, which is 1, is our degree. Right? Or just write the given differential equation as d cube y plus d square y minus dy minus 1 into y is minus y equals to cos 2x. We know that differential operator d equals to dy dx. Then d square will be d square by dx square and d cube will be d cube by dx cube. Right? So we can write d cube y as d cube y by dx cube plus d square y by d square y by dx square minus dy as dy by dx minus y equals to cos 2x. So here the highest derivative is d cube y by dx cube. So our order will be 3 and the highest power of the highest derivative is our degree. Degree is 1. Now coming to the problem. We are given a differential equation which is in operator form. Right? Given differential equation d cube plus d square minus d minus 1 into y equals to cos 2x, which is in operator form. F of d into y equals to some q, where f of d equals to d cube plus d square minus d minus 1 and q equals to cos 2x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yb. Here yc is a complementary function. We'll get yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Just take or make just write RHS as 0, then we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q. Now firstly we'll find yc, complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d cube plus d square minus d minus 1, right? Now we can replace the differential operator d by m, so that we'll get f of m equals to m cube plus m square minus m minus 1. Then our auxiliary equation becomes m cube plus m square minus m minus 1 equals to 0. Right? Now, let's take m square common from the first two terms. We'll get m square times m plus 1. And take minus 1 common from the next two terms. We'll get minus of m plus 1 equals to 0. If you notice, we are having m plus 1 in both the terms, right? So we can take m plus 1 common now. Then we'll get m plus 1 into m square minus 1. Now equate each factor to 0. From m plus 1 equals to 0, we'll get m equals to minus 1. From m square minus 1 equals to 0, we can just write this 1 as 1 square, then you'll get m square minus 1 square equals to 0. Here m square minus 1 square is of a square minus b square form, so we can write it as m plus 1 into m minus 1 equals to 0. Again, equate each factor to 0, then from m plus 1 equals to 0, we'll get m equals to minus 1, and from m minus 1 equals to 0, you'll get m equals to plus 1, right? So we'll get roots m equals to, from m plus 1 equals to 0, only one root, minus 1, and from m square minus 1 equals to 0, we got two roots, right? By equating m plus 1 to 0 and m minus 1 to 0, we got m equals to minus 1 and m equals to 1. Okay, so we have two equal roots and one distinct root. Therefore, m equals to minus 1, 1 are the roots of f of m equals to 0, our auxiliary equation, which are equal and distinct. What I mean is, we have two equal roots and one distinct root. So let's write complementary function using these roots. We know that when two roots are equal, say m1 equals to m2, then our complementary function will be c1 plus c2x into e power that equal root into x, right? And for if we have one distinct root, say m cube, here I have used two roots m1 and m2, so I'm taking third root as some m3. If we have one root which is distinct, then our complementary function will be constant. We have already used c1, c2 constant, so we'll take another constant c3 into e power that distinct root into x. Now let's write for these three roots. The complementary function will be yc equals to c1 plus c2x into e power equal root minus 1 into x plus for distinct root another constant into e power this root into x. Then our yc will be c1 plus c2x into e power minus x plus c3 e power x. Or if we have written this roots as m equals to some 1 minus 1, then our yc will be, firstly we'll write for distinct root, c1 e power the distinct root into x plus e power equal root minus 1 into x into the constant, another constant. Here we have used c1, right? So let's take c2 and c3 here. Okay, then yc will be c1 e power x plus e power minus x into c2 plus c3x, or you can just write it as c2 plus c3x into e power minus 1 into x minus x. Okay, either you can write complementary function like this or like this. Okay, it's up to you. Now let's write, or let's find particular integral. Now we need to find particular integral. We know that particular integral is given by 1 by f of d into q. We have f of d, dq plus d square minus d minus 1 into q cos 2x, right? Which is in 1 by f of d into cos ax form. For a equals to 2, let's find d square, which is given by minus a square. Then for a equals to 2, you'll get minus 2 square, which is equals to minus 4, right? Now, consider f of d, the denominator part. Always we have to get denominator not equals to 0. Denominator must be not equals to 0. Okay? Consider denominator We can write d cube as d square into d plus d square minus d minus 1. Now let's replace d square by minus 4. We'll get minus 4 into d plus minus 4 minus d minus 1, which is equals to minus 4d minus into plus minus 4 minus d minus 1, which is equals to minus 4d minus d is minus 5d. Minus 4 minus 1 is minus 5, which is not equals to 0, right? Let's take minus 5 common, then we'll get minus 5 times d plus 1, which is not equals to 0. So we got to know that by replacing d square by minus 4 in the denominator, we'll get not equals to 0. The denominator will not become to 0, right? So now we can replace d square, okay? Just write d cube as d square into d plus d square minus d minus 1 into cos 2x, and now replace d square by minus a square, which is equals to minus 2 square, which is equals to minus 4. Then we'll get 1 by d square, replace d square by minus 4. We'll just write the same steps. Here we'll just do the rough part to check whether the denominator is equals to 0 or not equals to 0, into d plus replace d square by minus 4 minus d minus 1 into cos 2x. This becomes 1 by minus 4d plus into minus minus 4 minus d minus 1 into cos 2x, which is equals to 1 by minus 4d minus d is minus 5d minus 4 minus 1 is minus 5 into cos 2x. Now we'll take minus 5 common from the two terms of denominator. We'll get minus 5 times d plus 1. See, minus 5 into d is minus 5d minus into plus minus 5 into 1, 5. Which is equals to, you can just write it as 1 by minus 5 into 1 by d plus 1 into cos 2x. We can write 1 by minus 5 as minus 1 by 5 into 1 by d plus 1 into cos 2x, which is equals to minus 1 by 5 into, here we are having 1 by d plus 1. See, in the denominator we are having d plus 1, so we'll multiply and divide with, here we have plus, just replace it by minus and write the two terms as it is. Okay, we'll just multiply and divide by d minus 1 into cos 2x, equals to minus 1 by 5 into 1 into d minus 1 is d minus 1 by d plus 1 into d minus 1 into cos 2x. So the denominator is of a plus b into a minus b form, so we can write the denominator as a square minus b square, d square minus 1 square into cos 2x, which is equals to minus 1 by 5 into d minus 1 by d square minus 1 into cos 2x. You can write this as minus 1 by 5 into, we'll just write as it is, okay. Now again, d square appears in the denominator. So what we have to do? We have to again check the denominator by replacing d square by minus 4. Replace d square by minus 4, you get minus 4 minus 1, which is equals to minus 5. Since it is not equals to 0, so we can dare to replace d square by minus 4. Always denominator must be not equals to 0. If we get denominator equals to 0, then we get some d minus 1. I'm talking about this term, okay? So anything by 0 is undefined, right? So the total yb becomes undefined if we get the denominator 0. That's the reason why we check the denominator when d square appears in it. Now let's replace d square by minus 4. Then we'll get d minus 1 by minus 4 minus 1 into cos 2x, which is equals to minus 1 by 5 into d minus 1 by minus 5 into cos 2x. You can again write this as 1 by minus 5 into d minus 1 into cos 2x, which is equal to minus 1 by 5 into, you can write 1 by minus 5 as minus 1 by 5 into the remaining terms as it is, right? So here this becomes minus 1 into minus 1 is plus 1 by 5 5s are 25 into d cos 2x minus 1 into cos 2x is cos 2x. We know that d is a differential operator since we know that d equals to d by dx. Then we need to find here derivative of cos 2x minus cos 2x, which is equals to 1 by 25 into derivative of cos 2x is minus 2 sine 2x minus cos 2x. Now we can take minus common from these two terms, we'll get minus 1, or better, take minus common inside the brackets, we'll get minus of 2 sine 2x plus cos 2x, right, which is equals to minus 1, 1 into minus 1 is minus 1 obviously, by 25 into 2 sine 2x plus cos 2x, or you can just write it as minus 1 into 1 by 25 times, you'll just write minus 1 into, you can just split minus 1 by 25 as minus 1 into 1 by 25 for our convenience, okay? We'll just take 1 by 25 inside the brackets. Then yp becomes minus 1 into 1 by 25 into 2 sine 2x is 2 by 25 sine 2x plus 1 by 25 into cos 2x, right? Simply minus of 2 sine, take the LCM from these two terms, you'll get 25 as your LCM, and then in the numerator you'll get 2 sine 2x plus cos 2x, okay? Or without confusion, you don't need to do all this, just take this 25 under brackets, okay? Much better. Then this will be equals to minus 2 sine 2x plus cos 2x by 25. You'll get the same thing. Therefore, yp equals to minus of 2 sine 2x plus cos 2x by 25. Now let's write general solution. The general solution is given by y equals to yc plus yp. Then y equals to, you can choose any of these yc. Okay, I'll choose the second one. c1 e power x plus c2 plus c3x into e power minus x plus yp minus of 2 sine 2x plus cos 2x by 25, or y equals to c1 e power x plus c2 plus c3x e power minus x minus of 2 by 25 sine 2x plus 1 by 25 into cos 2x, okay? Or just change the first yc, okay? You can choose any of these two. So this completes the problem. can write the solution in any of these four forms. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.